Good afternoon to all of you. Hello, I am Saikat Giri, your chemistry lecturer. Today, we are going to discuss one of the most important chapter in physical chemistry considered as electrochemistry. It is in class 12th part. Generally, students feels that this topic is tough because it is connected to many topics like stoichiometry 1, 2 and 3, that is redox reactions, mole concept. With that, it is connected with chemical and ionic equilibrium as well as thermodynamics. So, you should have knowledge in these topics to understand the chapter properly. I will try to make this chapter easier for you, and here I am going to take approximately 13 to 14 lectures to discuss all the questions and varieties properly. So, today we are going to start with electrochemistry's first part, that is electrochemical cell. Basically, electrochemistry divided into two parts. One is electrochemical cell, another one is electrolytic cell. So, we are going to start with electrochemical cell. This is our first topic of discussion. Let's see what is electrochemical cell. As the name signifies, electrochemical means electrical and chemical energies they are talking about. Means a cell that is helping to interconvert electrical and chemical energies to each other, considered as electrochemical cell. Electrochemical cell divided into two parts, galvanic or voltaic cell, first part. Second part is considered as electrolytic cell. So, we are going to take the definition, then I am going to show you the divisions. So, first part, what is electrochemical cell? That is device used to interconvert electrical and chemical energies to each other, known as electrochemical cell. It has basically two types of electrochemical cell are observed. First part is considered as galvanic or voltaic cell, and second part is considered as electrolytic cell. What do you mean by galvanic cell or voltaic cell? We can say that galvanic cell, that cell used to transfer chemical energy to electrical energy. So it is used for chemical energy converted to electrical energy. That is considered as galvanic cell. Now, what is electrolytic cell? Electrolytic cell is here electrical energy, you can say electrical energy converted to chemical energy. That is the understanding of electrolytic and galvanic cell. Another criteria, in this case the reaction is considered to be spontaneous, means we can say that electrical flow due to spontaneous reaction. Here electrical flow, it is a non-spontaneous process. Here external battery is used to maintain electrical flow, to maintain electrical flow. So in this case, two type of cells, one is galvanic, one is voltaic. One is galvanic or voltaic, another one is electrolytic cell. So here is two type of cells we are discussing about, galvanic and electrolytic. In case of galvanic, chemical to electrical. In case of electrolytic, electrical to chemical conversion takes place. Here this reaction is spontaneous. What is the meaning of spontaneous reaction? The reaction that happens by its own without the help of any external agency, or after initiation no further help is required, then it is considered as a galvanic spontaneous process that happens under galvanic cell. But in case of electrolytic cell, it does not happen by its own. We have to connect one external battery to give supply of current so that the reaction takes place in the cell. Let's go to the third property. Now we are going to discuss the third property for galvanic cell. For galvanic cell, we can say third property is, here anode is negative and cathode considered as positive. But always keeps in mind that anode negative, cathode positive, anode charge can be changed. It can be positive. This cathode can be negative as well in different type of cells. But in anode always oxidation happens. It is mandatory that here oxidation, and in cathode reduction happens. It never changes. Whenever we are taking for electrolytic cell, we can consider in case of electrolytic cell, here anode is positive and here cathode is negative. But in case of anode, oxidation will happen, there is no reduction. And in case of cathode, there a reduction will happen, there is no point of oxidation. So whenever we are discussing about electrochemistry in electrochemical cell, we have to keep these two things in mind. Now let's elaborately discuss the galvanic cell or voltaic cell, that is also known as Daniell cell. Now what do you mean by galvanic cell? Basically, this cell we already discussed. What are the characteristics? This cell is also known as Daniell cell. And all the cells have basic construction like galvanic cell only or Daniell cell only. Now we are going to decide which one is cathode, which one is anode, and why. Let's talk about zinc. First we are taking about zinc. Zinc is here considered as zinc copper system we are going to take. So zinc copper, from these two we have to decide which one is cathode and which one is anode. Starting with zinc. So zinc is, we can say, it is more electropositive. Why? Because it has +2 charge. As zinc is more electropositive, there is one more logic for electropositivity. Zinc is present in above position in electrochemical series. Zinc is more electropositive. As a result, it has more tendency. To donate electrons. So it will always try to donate electrons. As it has more tendency to donate electron, it is, we can consider, more electropositive. Also, as high electron donating tendency is there, means it can be easily oxidized, means it can be easily oxidized. As it is easily oxidized, zinc behaves as anode. Now in case of copper, if you are considering in case of copper is less electropositive in comparison to zinc, so it has less tendency to donate electron, it prefer to accept electron, less tendency to donate electron, and it has more tendency to accept electron. As it has more tendency to accept electron, then it is easily reduced. As it is easily reduced, it will behave as a cathode. We know that in anode terminal oxidation takes place and in cathode terminal reduction takes place. So this is the basic idea about the cell, how zinc and copper can be used. Construction. How the cell is made and how we are going to draw different type of forms. See. First we are taking two containers. In this case, left side we consider as anode. In this case, zinc anode is connected. Here we are connecting zinc anode. This is our zinc anode. In left side, anode is negative terminal. So this is our negative terminal. In the right side, we have, in the right side terminal, we have copper cathode and it is a positive terminal. They both are connected by an electrical wire and here one galvanometer is connected. Here one galvanometer is connected. This is our galvanometer. The solution of ZnSO4 taken here. This is ZnSO4 solution. ZnSO4 aqueous medium. It breaks as Zn2 plus SO4 2 minus. Both are in aqueous phase. In case of copper, we are considering here copper sulfate solution is present. In this case, copper sulfate is present. It breaks as, this is in aqueous state, Cu2 plus aqueous plus SO4 2 minus aqueous, and copper sulfate is in aqueous state. This is our cathode terminal and this is anode terminal. Now what is going to happen? Generally we connect a salt bridge, but before salt bridge, let us discuss few things about these parameters. What happens? In this cell, this cell donates Zn2 plus. As a result, here solution becomes electropositive and electrons are accommodated in this cell. We can draw electrons here. Electrons are present here. It is accumulated. And in this direction, there is flow of electron. So current will flow in opposite direction. This is the direction of flow of current. This is the direction of flow of electron. Always direction of flow of electron and direction of flow of current will be opposite to each other. In this case, in case of copper, what happens? These electrons are accumulated here. As a result, accumulation happens and this becomes thicker and this becomes thinner. Here Cu2 plus adds 2 electron and here copper is accumulated. In this case, copper is accumulated. As copper accumulated, it becomes thicker with respect to time and here it is dissociated. Here dissociation happens. Dissociation. As a result, it becomes thinner with respect to time. Now, first question is, will this cell work? Will this cell work? Answer is no, it will not work. Why it will not work? Because it is not connected. What will happen? In this case, zinc will dissociate to Zn2 plus SO4 2 minus. So Zn2 plus is electropositive in nature. As Zn2 plus is going to accumulate or going to be coming to this solution, Zn2 plus is coming to this solution, this aqueous solution. So electrons are accumulated in the anode. As a result, electrons are accumulated in the anode, it becomes negative. So to become neutral, it will again take Zn2 plus to its terminal again. Now what will happen? Now the work starts like, one case it is liberating electron, another case electron is accepting Zn2 plus. So ultimately cell stops working. So here work will not happen. Let's discuss working of the cell. How the anode is going to work in this system, we are going to check that. We know that zinc is electropositive in nature. Zinc is more electropositive than copper. As a result, zinc will liberate 2 electrons with Zn2 plus. So, as zinc liberates 2 electrons, in that case, it is liberating positive charge to the solution. So, the solution becomes positive and 2 electrons are left in the solution. Left 2 electrons are accumulated by the electrode and it becomes negative and solution becomes positive because of Zn2 plus. So, in case of anode, because of Zn2 plus, this solution is positive in nature. This is a positive solution in nature. But this electrode is negative in nature. Whenever zinc to Zn2 plus, so it is 0 to 2 plus. This process is considered as oxidation. So, whenever oxidation is happening, we can say that when oxidation is happening or oxidation is happening in the negative terminal, so we consider anode as negative. Now what will happen now? As this becomes positive and the electrode becomes negative, to become neutral, it will take Zn2 plus again. As a result, the whole cell stops working. So oxidation and reduction both happen simultaneously. From here to here, oxidation happens. Again, it takes Zn2 plus electron and reduction happens. So when oxidation reduction happening together in a cell, we consider it as here cell is not working. That's why when I have asked, is this cell working? Answer is no, cell is not working. This is the working principle of anode. Now how the cathode works, and this is the cell reaction in case of anode. What happens in the cathode terminal? Let's discuss for cathode as well. So we are going to discuss working of cathode. How the cathode terminal is working. Working of cathode. How this will work? In case of cathode, we know copper is less electropositive in comparison to zinc. So respectively, copper is electronegative. So in case of this case, its cell reaction is Cu2 plus aqueous plus 2 electron, it is going to give copper. Whereas 2 plus 2, 0. This is considered as reduction. So here reduction is happening. So what happens in the cell? In this cell, Cu2 plus that is present in the cell, it is being accumulated here. And this solution is considered as electronegative. Here electrons are revolving all over. And the present Cu2 plus that is being accumulated in this cathode. As a result, cathode becomes thicker with respect to time. So what is the basic working? Let's discuss in detail. Whenever in case of cathode terminal, we consider it as electropositive. We consider cathode as electropositive, but copper is respectively electronegative with respect to zinc, or you can say it is less electropositive in nature. As a result, it has a tendency to accept electron and becomes positive. Here, this solution is respectively electronegative in nature. And this terminal, it accepts Cu2 plus and becomes copper. As a result, accumulation happens in case of cathode terminal and a dissociation happens in case of anode terminal. From anode terminal, there is a flow of electron. From cathode terminal, there is a flow of current. But here also, after oxidation, reduction happens again. So cell does not work. So my target is how to make this cell working. To make this cell working, what I have to do? I have to basically connect. What do we have to do? We have to basically connect one salt bridge. We have to basically connect one salt bridge over here. We are going to connect one salt bridge. This salt bridge will complete the cell. So it will work as a complete cell. And in this case, as the circular working is happening, means from cathode Cu2 plus is produced, again electron produced, it is accumulated, it is revolving here only, then it will not happen. It will behave as a normal cell and it will start working. So this is known as salt bridge. This is known as salt bridge. To maintain electrical neutrality, salt bridge is used. So how the salt bridge will work and how it makes the cell working, let's discuss about it. So we are going to discuss about salt bridge. What is a salt bridge? It is a jelly-like paste or paste of inert electrolyte. It is a jelly-like paste of inert electrolyte of gelatin or agar-agar solution in an inverted U-shaped tube. So, what are the few examples of salt bridge and how it is made? It is made by gelatin or agar-agar type solution in an inverted U-shaped tube. What does it do? Let's note down the working of this and take few examples. Let's take, what are some examples of salt bridge? We can take KCl, KNO3, NH4Cl, NH4NO3, etc. Here one thing is very important to understand. In this case, the speed of K plus and Cl minus is equal. The speed of K plus and Cl minus, or the velocity of K plus Cl minus is equal. NH4 plus Cl minus is equal. NH4 plus NO3 minus is equal. K plus NO3 minus is equal. Why their speed is exactly the same? We'll understand in some time. So, what is the working of salt bridge? First, working of salt bridge or importance of salt bridge. What does it do? First thing, it maintains electrical neutrality by supplying cation and anion. By supplying cation and anion. So it maintains electrical neutrality by supply of cation and anion. Second thing, it stops intermixing of solution. It stops intermixing of solution, so that both solution does not intermix with each other, and then in that case we couldn't find out anything what is happening in the cell. And one of the most important work of this cell, it completes internal circuit of the cell. Now let's understand its working properly. What happens? In case of salt bridge, let us consider we have taken one solution. Here Zn2 plus is produced. Now this Zn2 plus is going to give the supply of electron. Now these electrons are being accumulated in the electrode terminal. As a result, when it becomes negative, it needs the positive charge to become stable or to become neutral. But as there is no option to take positive charge, it takes the positive charge from the solution only. As a result, reaction stops. But whenever you are taking KCl or KNO3, what will happen? This K plus, it is a negative terminal. It is negative charged. So it needs the supply of positive charge. Here 2 electrons are there. As a result, 2K plus will come here and it will maintain the electrical neutrality. So it will not take Zn2 plus from the solution. In this case, here what will happen? It needs positive charge because its electrode is positive in nature, solution negative, but this electrode is positive in nature. As electrode is positive, it needs negative charge, and here also 2 negative charge is there. So here Cl minus, 2 Cl minus will be supplied to maintain its electrical neutrality. So here also cell reaction will not stop. As a result, the complete cell starts working. Now one more thing I have told you, that their speed need to be same. Why? Why speed need to be same? Let us consider speed of supplying K plus and speed of Cl minus is different. Now let us consider K plus supplied here, but Cl minus is not supplied here. So in this case, cell reaction will stop. As a result, again cell is not completed. Same, if Cl minus speed is more, then K plus is not being supplied. It will take positive charge from Zn2 plus. So cell is basically not working. As a result, what do we need to do? We need to consider that both have equal speed so that the cell starts working and the construction of the cell is complete. That's why we say that it completes the internal circuit of the cell. Now, salt bridge has some more understandings. Let's look after that. I can draw this in another way as well. Let me show you one. It is important to understand. So, how it can be drawn? It can be drawn like, let us consider this is our complete electrolytic container, and in this case we have zinc anode in the left side. Here we have zinc anode, and in the right side we have, it will be thicker, we have copper cathode. So here we have zinc anode, here copper cathode. Here zinc terminal we consider as negative, this we consider as positive. Why? We already discussed. Now in this case, what is salt bridge? It behaves like this. Here positive, so in this case negative charge need to be connected. If you want to draw shape wise, then also you can see this is negative. In this case, what is needed? Negative charge is there, so supply of positive charge is needed. Negative sign or negative charge is always bigger with respect to positive charge, so we are drawing it big. So this is our SPM. What is SPM? SPM is semi permeable membrane that does not allow all the solvent to pass. So in this case, what happens? This is our SPM. So it is behaving as a salt bridge. It is supplying positive charge here, it is supplying negative charge here. In the solution, in such a way it maintains electrical neutrality. You can see the separation over here. As the cells are over here, in this case, the liquids that are present in cathode and anode, they are being separated. It is actually, you can consider like आप इसको एक पर्दे जैसा सोच सकते हो. एक पर्दा है और उस पर्दे के दोनों तरफ पॉजिटिव और नेगेटिव चार्ज प्रेजेंट है. जिसको पॉजिटिव की जरूरत है ये पॉजिटिव का सप्लाई देता है, जिसको नेगेटिव की जरूरत है ये नेगेटिव का सप्लाई देता है. ठीक इसी तरीके से हमारी सॉल्ट ब्रिज काम करता है और सेल रिएक्शन को कंप्लीट करता है. सो हमारा कंप्लीट सेल रिएक्शन क्या हुआ देखते हैं. सो इन एनोड टर्मिनल हमने पढ़ा है कि एनोड में क्या होता है. इन एनोड टर्मिनल जनरली ऑक्सीडेशन हैपेंस, इट इज नेगेटिव. ऑक्सीडेशन माने इलेक्ट्रॉन का रिमूवल होना चाहिए. सो जिंक ट्रांसफरिंग टू जिंक सॉलिड यू कैन राइट गिव्स Zn2 plus aqueous plus 2 इलेक्ट्रॉन. और कॉपर क्या करता है? दैट इज कैथोड टर्मिनल. In case of cathode terminal, in anode oxidation happens, in cathode reduction happens. In cathode, Cu2 plus aqueous, it takes 2 electrons and it becomes copper, that is solid. Now, what is the overall cell reaction? So we can write that is overall reaction or net reaction. Zinc solid plus Cu2 plus aqueous, it gives Zn2 plus aqueous plus copper solid. So this is our complete cell reaction for any electrochemical cell, better to say for any Daniell cell. When an external cell is connected, what is going to happen in a galvanic cell? So we can write effect of an external battery. It is effect of an external battery connected to galvanic cell. What will happen if we connect one external battery to the cell? Let's draw the cell diagram again. So this is the cell diagram that we have read before as well. This is one container, it is another container where electrolysis is happening. Here we have used zinc. This is our zinc anode, that is negative, and this is our copper cathode, that is positive, and they are connected to each other through a galvanometer. This is one galvanometer. Both the cells are connected via salt bridge, that is one inverted U-shaped tube that is made up of gelatin or agar-agar solution that gives supply of positive and negative charge. Also for basic construction we use NH4Cl, NaNO3, etc. Now we are going to connect one external battery with this. So here one external battery we are taking, that we are going to connect with this. This is the negative terminal. So in this side we are going to connect one positive terminal. You have to keep in mind the connection how we are doing. It is one rheostat. With this resistance one rheostat is connected. Now we'll look after what is going to happen in the cell step by step. Let us consider this potential difference. Generally we consider in between these two cells the potential difference is 1.1 volt. So there may be three conditions possible. First condition, if I am taking case 1, if for this rheostat the potential difference is equal to 1.1. Another case I can consider, for this rheostat the potential difference is less than 1.1, and another case it may be greater than 1.1. So all three cases what is going to happen we are going to check. So potential difference in Daniell cell equal to 1.1 volt. The external battery connected, that is E external may have voltage. It may have voltage. There may be three cases possible. Case 1. In case 1, if E external is less than 1.1, if E external is less than 1.1, then this Daniell cell will be dominant. So as it is dominant, this will behave as a electrochemical cell. So flow of current from anode to cathode. So here flow of current from opposite direction, this is electron flow, this is current flow. So flow of current from cathode to anode and flow of electron from anode to cathode. Anode to cathode. What we can say? Flow of current from cathode to anode and a flow of electron from anode to cathode with E external less than 1.1. Let's take case 2. If we consider E external equal to 1.1, then there is no difference between the external battery and this. We are changing this. We are changing this to this like this. It can be changed like this. The rheostat is changed with respect to time. We are changing this actually. So what will happen now? If it is equal to 1.1, means if it is in the midpoint, then it is equal to 1.1. In this case, what is going to happen? So there is no potential difference. Potential difference is 0. So in this case, cell will not work. Here there is no work for the cell. Case 3 we are considering. Now rheostat is moved to the right side. In this case, E external is greater than 1.1. If E external is greater than 1.1, then the terminals zinc anode and here copper cathode. In the first case also, here zinc anode, copper cathode we considered, and in case of zinc anode is negative, copper cathode is positive. Here what is going to happen? Here this is the anode terminal, zinc anode, it is going to be with it was negative, now it will be positive, and copper cathode it is going to be negative. So it will behave like, this cell will behave like electrolytic cell. So the direction of flow of current and the direction of flow of electron will also change. I hope you understand this lecture about the basic construction, about salt bridge and how it will behave when external battery is connected to it. Next day we will start from the representations of electrochemical cells, how we can find out the redox reaction and how can we balance that, how can we write a cell reaction with respect to given different data, and if data is given, how can we construct a cell reaction with respect to that, we'll look after next day. Thank you everyone for being with me. Please help me to grow, and also you learn the topic properly. Let's learn and help people to learn. Don't forget to like and subscribe. Thank you everyone. Have a good day.